Hi, my name is John Joseph, and I'm going to introduce my procedural text generation tool, ProcGenie. ProcGenie is an open-source, browser-based procedural text generation tool. It enables the design of complex replacement grammars for procedural text generation. It allows probabilistic and constraint-based rule selection, state tracking, and deeply nested graphs and rules. ProcGenie also facilitates interactivity by allowing users to steer procedural text generation through dynamically generated choices, hyperlinks, and a parser. ProcGenie is at procgenie.github.io, and if you go there, you'll see this landing page. I'm going to walk through some simple navigational rules with ProcGenie. But first, let me give some background. ProcGenie is a tool for defining rewrite systems or grammars on a graph or a set of graphs and procedurally generating textual results. A rewrite system is an algorithm that applies rewrite rules. A grammar is a rewrite system used to define a language, and a language is essentially the universe that can be generated from a grammar. This usage of grammar is synonymous with the phrase replacement grammar. If you're familiar with Kate Compton's work on tracery, ProcGenie is based on a similar theoretical framework with some additional bells and whistles. Tracery is a tool for defining context-free grammars and generating procedural text in a similar way. Unlike tracery and other similar tools, the rewrite systems and grammars in ProcGenie are authored on graphs, like you'll see here on the landing page, and they're encoded with context, state, probability, flow control, and interactivity. Now, over the course of this series, we're going to walk through the syntax of ProcGenie, how we add each of these elements to your graph. But before we do, just some simple background on our goals with ProcGenie. ProcGenie aims to reduce the burden of complex procedural text generation. I use the word complex as shorthand to describe procedural generation of hand-authored, long-form, or potentially long-form, consistent, meaningful, and potentially interactive text. I'll distinguish complex generation from other forms of procedural text generation, not by the sophistication of underlying methods, but by the complexity of the ultimate goal. So the goal is not necessarily to write Twitter bots, although you could do that with ProcGenie. It's to write longer form interactive experiences. Now, this is a difficult thing to implement. It's time consuming to author, complicated in reasoning execution. It can be frustrating in development. So if a more lightweight approach would serve your project's purpose, then I would encourage you to look to other means. But if you're looking for this kind of long-form, interactive, procedural text generation, then I hope that ProcGenie might be right for you. ProcGenie attempts to address this problem space in several ways. So first, it facilitates authoring by providing a browser-based user interface, which allows relatively easy hand authoring of complex graph-based replacement grammars. These can be exported to JSON format, they can be generated in browser, you can save them locally, load them from your local storage. Second, ProcGenie facilitates coherence, internal consistency, and meaning by tracking state and tags at each step of the procedural text generation process, checking that state against the next possible steps of the generation process, and interpolating that state where desired. Third, ProcGenie facilitates interactivity by allowing users of the tool to create choices, hyperlinks, and parser entries that encode their procedurally generated context and generate from that context when action is taken, for example, by clicking on a choice. Fourth, ProcGenie facilitates long-form generation through the use of graphs, the organization of production rules, and our tracking of logic and state. And finally, we have several helper methods that can be used mid-process, post-process of procedural text generation that can be interjected right in the middle of your procedural text generation, like Markov chains based on the currently generated text up to a point. And then that can also be used to direct the course of procedural text generation. So taken together, I'd posit that these features are a modest step forward in tooling for complex procedural text generation. But let's get started with how we navigate the tool. If you're here at procgenie.github.io, go to the project page. This will bring you to this, what looks like a blank screen, but if you click on Graphs and Create Graph, you'll see the graph editor. Now this is kind of the heart and soul of ProcGenie. You have this graph, you can zoom in and out on the graph. You'll see here there's coordinates for your current cell in the graph. You can move up and down on the z-axis, so you have x, y, and z-axes here on the graph. And this is where you would define your grammars. The name of your current graph is down here at the bottom. You can also click on here, this is a list of the types of graphs you've defined. You see graph type here, graph name, this is where you would define a new graph. But if you click on the list, by default, every generator in ProcGenie starts with a default graph type and a graph named new grid. So this is the graph here. It's the new grid graph on the default graph type. At the top of the screen, you'll see menu options. You could click on the File menu. That's going to bring up new, local save, local load. These are local storage ways to save and load your generator. You can export your grid to JSON or go back to the home page that we were just looking at, the landing page. Now, if you export your grid to JSON, it's going to be something that you could load in and out of ProcGenie. And we can go into that later. Clicking on the Graphs menu, it brings up the Create Graph function here, the Change Theme. You can change the color of the generated text, color of generated hyperlinks, choices. But if we go back to Create Graph here, you'll be here on the main graph editor. And I'm going to start with a simple Hello World example. So every graph, the entry point for every graph is a start symbol or a number of start symbols. Here, we'll just define one start symbol here in this cell. And then we'll give it a directional rule. Now, what is a directional rule? It's a production rule that tells the ProcGenie generator where it can go next. And it's pretty straightforward. It's cardinal directions. So E means that it can go x plus 1. N means it can go y plus 1. Here we're going to tell it E for x plus 1, and we're going to say hello world. Now if we click the Run button, that'll be our first time generating text in ProcGenie. Hello world. What happened? Alright, so when you click Run, basically imagine a walker or a crawler that walks across. It's your generator walking across your graph. It's going to start walking here at the start symbol. It will see that it has the directional rule allowing it to go x plus 1. It moves to hello world, and it accumulates the text in that cell, or in the component in that cell. Now we're going to talk here in a second about components within cells, but for now just know that the walker starts here at the start symbol, gets a directional rule or production rule that allows it to move x plus 1, and picks up the text hello world. Again, clicking Run again, hello world. But what if you don't just want to write hello world? What if you want to have what we're supposed to be doing here, which is procedurally generating text? Well, there's a few different ways you could go about this, but we'll start by talking about directional rules again. Directional rules, you can define directional rules in a single set of brackets. You can define multiple directional rules. So I could put NE for northeast, or x and y plus 1, E for east, and SE for southeast. So hello, and here we could write world, mundo, everyone. Now, when you have multiple directional or production rules like this, ProcGenie is going to randomly choose between them based on which one of these component cells is available. So when I click the Run button, hello mundo, hello mundo, hello everyone, hello mundo, getting a lot of hello mundos on this one, hello world. Alright, so we had hello everyone, hello world, hello mundo. These directional rules allowed ProcGenie to choose randomly between these options. But what if we wanted to define that sort of procedural generation within a single cell? Well, you can do that too. Or if you want to add probabilities, you can do that too. You would click into a cell and use a pipe symbol to separate out the different options. Hello world, hello people, hello friends. Alright, so this pipe symbol here will separate out the different options, and that makes a different component. Each authored cell consists of one or more cell components. Now, in conceptual terms, the inclusion of a component in a cell defines a production rule that states that the cell, which is essentially, in grammar terms, is an anonymous non-terminal, that this cell consists of one or more cell components, and these could be anonymous non-terminals, they could be terminals, so they could be symbols that could be reduced to additional text or strings, or they could just be strings. So here, hello world, hello people, hello friends. Let's see what happens. Hello world. Why didn't we get hello people, hello friends? Well, if there are no constraints and no probabilities that are defined on a component, then the first component in the cell is selected. So here, every time hello world is going to be selected. If you want different components to be selected, then you'll need to add a probability. So probability is a probability factor, and it's just a number that you include in between brackets that tells the generator what probability factor to give to that component. Here, world is given a probability factor of 1. If the walker moves to this cell, it's going to add up all of the probability factors. Let's add 1 for each of the components. So 1, 1, and 1. And it'll place each factor within a range, and then it's pseudo-randomly going to pick a number between 1 and the sum of the factors. It will select the component with the probability factor that lies within that range. For example, if the generator picks 1 here, then it's going to click world, 2 people, 3 friends, or 1 world, 2 people, and then 3 through 7 would be friends. So let's see what happens when we click run. Hello friends. You would expect that, right? Hello mundo, hello friends. Hello friends is going to be picked largely above the others. But if we go back to 1, hello mundo, hello friends, hello everyone. So now we have essentially 5 different options that can be picked. 1 out of 3 times it'll pick everyone, 1 out of 3 times it'll pick mundo, 1 out of 3 times it will pick one of these 3 options, and it will pick between them on equal probability factors. So 1 out of 3 times it'll pick one of each of these of the times that this cell is picked. So those are the start symbol in ProcGenie, cells, and components. Now again, start is just a symbol that tells the generator where it can begin. The directional rules are essentially either cardinal directions, the first letter, second letter of cardinal directions, or U for up, D for down, going up or down on the z-axis. Cells are anonymous non-terminals, which means they're essentially symbols without a name that say that when you hit that cell, you can choose one of any component within that cell. And which component would be chosen? It's going to be based on probability factors, which we talked about today, or constraints, which we'll talk about later. Once you're done defining a grammar, you click on the Run button, and you get your generated text as a result. You press Escape to go back to the graph editor. And that's a basic introduction to some of the simplest text generation methods in ProcGenie. In future videos, we'll cover some of the more advanced topics.